Well, welcome to an introduction to statistics. In this lesson, we're going to answer the question, why statistics? Before we get started, though, I want to say a few introductory types of things. First of all, we're going to meet lots of new friends this term, so we'll call all of our statistical tools our friends, and we're going to be creating a statistical toolbox. So much like your toolbox at home, you need to know what tools are in the box, how to use those tools, when to use the tools, how to interpret the outcome of using the tools. So let's get started. Statistics, what is it? What is it not? There are two broad types of statistical tools, those that help us describe, organize, interpret data, and those that help us make decisions. Now when we talk about data, we're simply talking about singularly one observation on a particular person, and then we're going to be dealing with data sets, and so a set of observations. Throughout the class, we're going to introduce to you some comic relief. So I'll give you a second to read this little joke. One of the things that I think is important that you know is that statistics loves you. You just have to learn to love it back, and I know you will sooner than later. The type of statistics, or the branch of statistics that help us organize and describe data, are called descriptive statistics. Some of the things that fit into this category of statistics are the measures of central tendency and variability. And you might wonder why there's a picture of a mountain in the middle of the screen. That is actually Pikes Peak in Colorado. And I put it there because that actually represents something that's really beautiful, number one, but then also kind of the normal curve. So the highest point of the peak is in the center of it. You can see there. And so that reminds me of the measures of central tendency. And then the variability, or the spread outness of a set of data, you can see by looking at how the mountain actually tapers toward the edges of the mountain. The second branch of statistics is called inferential statistics. And you may have wondered on the previous slide why we would say that there's a branch of statistics, or one of the tools is it helps us make decisions with incomplete data, and that has to do with inferential statistics. Most of the time as a researcher you will not have access to everyone in a population, so we have to use sampling techniques, and when we use sampling techniques we measure information about the sample, and then we'd have to make generalizations back to our larger population. So inferential statistics are the tools that allow us to make inferences about a sample and then make generalizations back to the larger group, which is the population. I don't know how many of you watch DVDs at home. When I rent a DVD or have a DVD, I like to watch the movie through, and then often, if I have time, I'll sit down and listen to and watch the movie again as the director is speaking over, or maybe some of the actors are speaking over the movie itself. So that's what I feel like in here today, that I'm taking you through a movie, the journey of making a movie, in this case, our journey through statistics. So in the previous slide, I talked about a population. Population is a group that has at least one thing in common, and it is the group to which you want to refer back to after the research process. So an example of a population is all Aggies, and then a sample is a subset of that population. The next term is statistic, and notice that there's no S at the end of it. So a statistic is a summarized value of a sample. So if we're talking about age, and we sampled Aggies and we asked them what is their age, and we calculated the average age of that subset, that would be a statistic of our sample. And then lastly is the term parameter. Parameter is a summarized value of a population. So if we had access to all Aggies, found out their age, added all those ages up, divided by the number of Aggies, and we knew the average age of the all Aggies, that would be a parameter of the population. So again, trying to have a little comic relief here. So knock knock, who's there? Willie and Boris. Willie Boris who? Willie Boris in a stat lecture today. The answer is probably yes. Okay, let's talk a little bit about variables. A variable is a characteristic, or is the characteristic that you are measuring, so things like achievement or knowledge. Variables can be divided into two types. The first one is quantitative, the second one is qualitative. Quantitative variables imply that there are differing amounts of whatever it is that you are measuring, like runtime or speed. Qualitative variables indicate that there are different kinds rather than different amounts. So if we were talking about the different breeds of dogs. So qualitative is also referred to as categorical. Variables can also be divided into the types based on continuous or discrete variables. Variables that can take on any value are continuous variables, so the number of free throws made, score on a GRE, number of students in a class, versus discrete variables which take on a finite number of values. So marital status would be an example of that: single, married, separated, divorced, or widowed. Or class in school, freshmen, sophomore, junior, seniors. So it looks like we have a group of Aggie seniors in their boots. Another term that I'll throw in right here is a dichotomous variable. This is a discrete variable that specifically has two levels. So a good example of that is gender, either being male or female. Another division of variables or types of variables that we'll be examining that I want to talk about now is when we're dealing with only one variable at a time, which we'll be doing here at the very beginning of the term. That is considered to be univariate data. So an example is if we had some speeds or some ice skaters or something like that. So we're considering only one variable at a time. Bivariate data implies that you're considering two variables simultaneously. So if later on in the semester we'll be working with bivariate data, so things like looking at strength and throwing distance, and again the key there is that we're doing that simultaneously. We'll get into that in, I believe, Module 3. Alright, kind of the last thing we need to talk about in this lesson is the four levels of measurement. Knowing the levels of measurement are important because it helps the researcher decide what types of tests he or she can do, what tools can be used given the type of data that you're looking at. And again, there are four levels of measure that we need to be interested in. The first one is what are called nominal scale data. And if there was one word I would have you remember for nominal scale, it would be that nominal scale simply names. And so the number doesn't really give us any indication of amount of anything. It just represents, in this case, in this example, 1 is Italian, 2 is Irish, 3 is Asian, 4 is Hispanic. So numbers are simply used to name. The next level of measurement gives us a little bit more information, and what you're going to see as we go from nominal up through the 4, you're actually going to see that each of them gives you a little bit more and more information. So the next one is ordinal scale, and this is ranked data. And so you can see at the bottom there are some finishes in the 1984 Pikes Peak Marathon. So again, a little bit more information. What ranked data doesn't give you, though, is any difference in, or in this case, the difference between the first and the second person, the second and the third person. So I went ahead and did the math for you. For this race, the difference between the first and second person was about 11.5 minutes or so, and then the distance between the second and third person was a little bit over 3 minutes. But again, they're still ranked 1, 2, and 3. And I use this example because my husband ran it that year and came in 7th place. Good job, Mike. All right, the next scale of measure is interval scale. The thing that you would remember here is equal intervals. So the distances between any two numbers are the same. So the two-point difference between 3 and 5 is the same as the 2-point difference between 7 and 9. The same thing is true in the temperature example. So much of what we measure in kind of the social sciences are on this scale, interval scale, and then as well as the next scale. And I'll mention another term that you might want to write down. When we're on, or when we're using or measuring things that are on interval or ratio scale, that affords us to use what are referred to as parametric statistical techniques. What that means is the underlying distributions are assumed to be normal. So if we're looking at things like height, if we looked at all the heights of all the people in the United States, theoretically that has a normal distribution. And so that allows us to use parametric statistical techniques. Non-parametric statistical techniques are used for data that are nominal or when the underlying distribution is not normal or unknown. The last scale of measure is ratio scale, and the one difference in it and interval scale is that there is a true zero. So that implies that there can be zero of something or none of something. In the other undergraduate class, I kind of laughingly joke that we probably have all said after meeting someone for the first time, they have no personality. And the truth of the matter is that some things there actually cannot be the absence of them, but some there are. So some things that are considered to be ratio scale are things like height, weight, or light. So if I make the statement, Norman is twice as far as Dallas, Norman, Oklahoma, is twice as far as Dallas, that doesn't mean anything until I say from Bryan College Station. So the statement, Norman is twice as far as Dallas from Bryan College Station, makes sense. So the absolute zero kind of implies the starting point. Got to have a few Aggie jokes here and there. Did you know that there are 3 types of Aggies? Those that can count and those that can't. I can hear you laughing. So what's next? We're going to move on to A Picture is Worth 1,000 Words. This is a little picture of my youngest nephew's first day of pre-K, and probably most of you don't know me, and I don't know that you can tell by looking at this picture which one of these might look a little bit like me, but I will tell you he's the one that looks the scaredest and wondering what in the heck he's doing there, and it's this little man right here. So a picture is worth 1,000 words, whether it's smiley faces or what am I doing in pre-K. So that's where we're headed next.